Yeah, always start with a sigh. That's a good practice. Any of you future teachers?
Are you recording?
Yeah, I'm recording. It's too late. You sighed.
I was just trying to expel the air from my lungs, okay? It's a part of my breathing
That's the definition of a sigh. Okay. Well, I think it is. Okay.
Good afternoon. This is Mr. Precella, and we're going to look at radical and rational equations today. And first thing we're going to look at are rational equations. And to my understanding, y'all sort of looked at some rational equations at the end of class the last time. Oh, I guess my... Now is it on? Yeah.
Oh, yeah.
So I'm close that door. I don't want to disturb Sandra's class next door. So, rational equations. A rational number is any number that can be written as a fraction, one integer over another integer. So a rational equation is just an equation that has fractions. I'll say equation with fractions. Now, we're going to have a process to go through and solve these rational equations. We'll start off with an equation that has fractions, and then we'll go through and get an equation that doesn't have fractions.
Very much like that last quadratic formula problem we did on, that was a different book. No, it isn't. Right there. Yeah, you're right.
You find the least common denominator and you multiply through to eliminate the fractions. Now, there's one wrinkle here. Not all fractions are defined. When is a fraction undefined? When is a fraction undefined? When it's divided by zero. Good. When you have a number divided by 0, n over o, a number divided by 0, that says no, you can't do it. And if you think about the division algorithm, it should be obvious why that's the case. Let's look at a real basic example. 8 divided by 2. We say 8 divided by 2 is 4. Now, what did you learn first? Did you learn to multiply or did you learn to divide first? Multiply. Division is defined in terms of multiplication. We say 8 divided by 2 is equal to 4 because 4 times 2 gives you 8. Well, what about something like 7 divided by 0?
Or
anything divided by 0. What times 0 is going to give you 7. It doesn't matter what number you put here. When you multiply it by 0, what are you going to get? 0. That's why we say that there is nothing that can be used there. Hence, division by 0 is undefined. So that's one thing we have to do. Once we go through and solve these equations, we're going to have to verify that we don't get a denominator of 0. For example,
sometimes students don't believe it till they see it on a calculator. 7 divided by 0, look at this error message you'll get. Error, divide by 0. There are 2 error messages you'll get on a calculator like this. One of them is division by 0. The other one would be if we had the square root of a negative number. We know the square root of negative 25 is what? 5i. But this calculator only works with real numbers. So if you get an answer, non-real answer, if you get that error, that means that you're getting an imaginary number. If you get that other error, what was it? Just error, divide by 0. Sometimes students say 0 over 0 is 1. No. 0 divided by 0, is it 1? No. You still get that error message. Show them why 0 divided by 0 isn't 1.
Okay. Realize that a quotient has to be unique. 8 divided by 2 is 4. There's not another number that you can multiply by 2 to give you 8. What about 0 divided by 0?
If you think
what number times 0 will give you 0?
Well, suppose put 1.
It could be 1, or it could be 7. It could be any number, right? So it's not unique. The quotient isn't unique. Hence, even 0 divided by 0 is undefined. If there's a denominator of 0 in the fraction's undefined. Looking at number 1, they're going to give us a rational equation, and this is number 1. What values of the variable cannot possibly be solutions for the given equation? Don't actually solve the equation, just they're asking us what numbers can not possibly be solutions. We have the fraction 8 over 2x plus 5 minus a 1 over x plus 5.
X minus 5.
X minus 5 is equal to 0.
So it's not asking you to solve this one. The first two problems, it doesn't say solve it. It's almost the exact opposite. It says what numbers, if you're going to guess, can't be answers.
Okay. We see two different denominators. Neither denominators can be 0. So 2x plus 5 can't be 0, and x minus 5 can't be 0. Well, solving this first equation, we'd move the 5 over and get that 2x cannot equal. When you move the 5 over, it becomes negative 5, and then we'll divide by 2. So here's the first number that x cannot possibly equal. Notice I have a little equals with a slash through it. X cannot equal negative 5 halves. So there's the first number that x cannot possibly equal.
Because if it were, you'd have 8 over 0.
The second one, this one's easier. Moving that constant over, we get that x cannot equal the negative 5. When you move it over, becomes 5. So there are the two numbers that you cannot possibly have as solutions. We don't know what the solutions are, but we know that they're not going to be a negative 5 halves, and it's not going to be a positive 5.
They could have worded this instructions to say, when are these fractions undefined? Maybe that would have been better. But negative 5 over 2, comma 5. What did I do wrong? Yeah, that comma 5 shouldn't be in the denominator. I'll hit right arrow, comma 5. Check it.
Okay, number 2 asks the same thing. We're not solving the equation, we're just going to find which numbers can't possibly be solutions. We have the fraction 1 over x minus 1 plus the fraction 1 over x plus 4 is equal to the fraction 1 over x squared plus 3x minus 4.
Two of these are pretty easy to figure out. There's 3 fractions here. Which of the 2 fractions are the easy ones to figure out? The first two. What makes this one difficult here? That x squared?
So we said the first, none of the denominators can be 0, so x minus 1 can't equal 0, x plus 4 can't equal 0, and x squared plus 3x minus 4 can't be 0. So what are we going to get from that first statement? X minus 1 can't be 0. That means x cannot equal 1, okay? So there's the first number that cannot possibly be a solution. If you try to plug in 1, you're going to get 1 over 0, undefined. What about the second one? X cannot equal -4, I agree. Can't plug in -4 because if you do, you get another 1 over 0. The third one, well, it's set equal to 0 at least, and it's a simple trinomial, so hopefully it won't be too difficult to factor. I'll write my 2 sets of parentheses.
Now, what makes
X squared. It's a simple trinomial that doing the first terms are easy. What are we going to use? 1x times 1x. What do we know about the signs? Okay, so they're going to be different. And to get a 4, you need either a 1 times 4 or a 2 times 2. 1 times 4 or 2 times 2. For a simple trinomial, in this case, you need the pair that subtracts to give you what? 3. So you're going to use 1 and 4. Put the 1 and the 4. Now play around. What should we have with the 1? A plus or a minus? In order to get back to plus 3x, hey, look at those factors. X minus 1 and x plus 4, they look familiar. Where did I see those? Oh, I know, the original denominators. So that trinomial factors in terms of the first two denominators, and that's not that rare. Are we going to get anything new here? When is x minus 1 equal to 0? Positive 1. When is x plus 4 equal to 0? -4. We already had the solutions. 1 and -4.
And I think it's rigged where this will always be a factor as to those two there. So I forgot what, oh wait,
1 and -4.
Comma -4.
And it's going to stop being quite so fast now because they're through just asking us what numbers can't be solutions. Now we're going to have to start solving the solutions. Solving the equations.
And finding the solutions.
Finding the solutions. Switch over. I have some writing I need to do. To solve a rational equation, these steps are pretty short when you write them out. It's going to sound very painless, but anyway, the first thing we're going to do, we're going to multiply both sides of the equation by the least common denominator. Now, when we multiply both sides by the least common denominator, we're going to be distributing. So I'm going to say, step 1, multiply both sides. And I'm going to put a little parenthetical statement here saying distribute. Then I have to distribute that least common denominator through all the terms. Multiply both sides by the least common denominator.
Theoretically, any common denominator would work, but
unless you want to get very messy reduction, you'll use the least common denominator. And as we go through the examples, we'll be discussing how do you find those least common denominators, okay? So the second step, you should, if you do this multiplication correctly, you should be able to cross-cancel all of the denominators. The equation you have left shouldn't have any fractions in it. I'll say cross-cancel so that no fractions remain. Step number 3. Once you've cross-canceled, you have an equation. They'll probably be quadratic, like the ones you were doing the last time, factoring in the quadratic formula. So it'll be an equation that you can solve. So I'll say solve the equation. And there's one extra step. Once you've solved the equation, you need to make sure, remember we started off with something that had fractions. We solved something without fractions. So you're going to need to make sure that the numbers you get don't give you denominators of 0. It is possible. Multiplying both sides of an equation by a variable quantity does not guarantee equivalence. You can't be 100% certain that the solutions of the new equation that you created are the same as the solutions of the original equation. So I want to say, verify that your solutions do not give you a denominator of 0. How about this? I'll say cross out any solutions that give a denominator of 0.
That's why you were doing problems 1 and 2.
If we had solved number 2 and we'd solved it and found out that one of the solutions was 1, we'd have to cross it out because 1 would give a denominator of 0. And let's go on to number 3. Okay, don't start writing this problem down. I want you to see how I write it down before. I think and there's no way I'm going to get it done on just that half a sheet of paper. So this is number 3. Okay, 4x plus 5 all over 4. Wait a minute, let me write this down and then I'll show you how I've written it down.
He's going to spread it out because he's going to have to multiply straight through by something. Ooh.
Yeah.
No. Let me flip over.
Okay, flip over. Notice how I'm spreading out. I'm going to have to multiply through by the least common denominator. And we'll discuss how to find that in a moment. But I'm going to be putting that LCD, the least common denominator standard abbreviation is LCD. You would have heard that phrase back when you were learning to add and subtract fractions. I'm going to put that least common denominator. I'll write it here, here, and over here. Realize this first fraction is a single term. A fraction by itself is a single term. So we have one term, a second term, and then on the other side we have a third term. There are 3 terms there. We're going to have to multiply by the least common denominator 3 different times. To determine the least common denominator, look at the denominators that appear. 4 and x minus 3. Can you factor those things? Well, that's just a number, so no, you're not going to factor that. What about x minus 3? Can x minus 3 be factored? No, if it's going to be factored, you'd expect to see some exponents on it. If you have 2 distinct denominators, neither of which can be factored. If you have 2 distinct denominators that are not factorable, the least common denominator will be the product of the denominators, 4 times x minus 3.
Here's where it gets a little messy.
Yeah, this is where it gets a little messy. We're going to have to distribute that 4 times x minus 3 across all 3 terms. So the first one, I'm going to multiply by 4 times x minus 3. And just to make a point that this 4 times x minus 3 is in the numerator, I'm going to put it all over 1. Here, multiply this by 4 times x minus 3. and multiply the x by 4 times x minus 3. So everyone read what I've written there. There's an x times 4 times x minus 3. So we've done the first step. We've multiplied both sides by the least common denominator. Second step, we're going to start canceling. And if we do this correctly, there shouldn't be any fractions remaining. So here's my red pen. Well, I have that 4 there in the original fraction. Let's look over here. Yeah, there's a factor of 4 I can cancel. Cancel the 4s. You say, well, you still have that denominator of 1. Yeah, we don't have to show that anymore. We can drop that denominator of 1. What have we got from the first term? We now have a blue x minus 3 times the black 4x plus 5. That thing right there, that minus, that's what I'm writing there. Trying to show it in green.
It just looks black to me.
Yeah.
But,
me too. Now the second product. We have to cancel out everything from the denominator except the 1. Or we can cancel that x minus 3 in the denominator with the x minus 3 on top. So we just have a 4 times a 5x. Now the third product, what's going to cancel? Say nothing. Nothing because there's no fraction, so nothing's going to cancel. To multiply, you just multiply from left to right. X times 4 is 4x. So you have 4x that you're going to have to distribute over x minus 3. Did y'all follow my logic there? X times 4 is 4x. I'll distribute in a moment.
So you're going to distribute here. Just multiply here. I'm looking for a 4-letter word that starts with F, dealing with algebra.
What are we going to do here? FOIL, okay. X times 4x, that's 4x squared first. Outer, x times 5 is a plus 5x. Inner, what's the inner product? Negative 12x, I agree. And negative 3 times positive 5, what's the last product? Okay. And now we have that minus sign. That's the minus from the original problem. 4 times 5x, that's 20x. And here, we have 4x times x minus 3. We'll have to distribute. Distributing the 4x times x gives me 4x squared, I agree, minus 4x times that minus 3 gives me a minus 12x. Okay. That's why this is the first problem. I was thinking, this seems like a messy problem for the first one that we have to solve. Do y'all see what I'm seeing?
About.
Look at that 4x squared and 4x squared. It's quadratic, or so we think, but when we move this 4x squared over and combine it with this 4x squared, what's about to happen? Minus 4x. If we try to combine those x squared terms, yeah, this is actually a good first problem. 4x squared minus 4x squared is gone. This thing is not quadratic. We're not going to have to try to ultimately factor or use the quadratic formula. Let's see, maybe we should clean this up. Yeah. 5x minus 12x, that's a negative 7x.
But you also have the minus 20.
Oh, I didn't see that one. 5 minus 12 is a negative 7. Minus 20, that's a negative 27x. And what do we have here on the right? We also have that minus 15. On the left equals, and on the right we have that negative 12x.
So this terminology is sort of important. We've gone from a rational equation, that's the thing with the fractions. For a moment, we thought we had a quadratic equation because we saw x squared, but now we have what type of equation? What's the name of the one where there's no exponent? Starts with L. Linear, yes. Okay. Oh, gosh. Oh, wow, Tim, this looks terrible.
Question? Well, we're going to have to. We're going to combine the x terms together. We have to get all of the x terms on one side. We're not through, okay? Oh, I see. You're saying to cancel that out right there.
Oh, that would have been good.
It's just a coincidence that those numbers are the same. I would bet on the one that you do, they won't be the same.
But that's a good observation. If I'd seen it.
Yeah, you're right. If I noticed it, I'm going to consider doing that.
But you heard, why don't we just go plus 12x, and those 12x's will be gone. Wow.
Okay,
that's a smart thing to do.
I didn't notice it, okay? Well, here's what I'm going to do. I'm going to get all of the x terms on one side of the equation, and I think I'm going to do it in a way so that we're minimizing negatives. I think I'll add the 27x to both sides. I'm going to get my x over on the right rather than on the left. So I'll say add 27x to both sides. And that'll give me a negative 15 is equal to, what's negative 12x plus 27x? 15x. What are we going to do to get rid of that 15 in front of x? Divide by 15 to give us x equals negative 15 divided by 15 is negative 1. So
going back to that idea, if that happens, do that. That was a very good suggestion of adding the 12x the way you suggested. I hadn't even noticed that.
Yes, you could.
Oh, yes, you provided you have minus 12, the same number on both sides. Okay, but that's just sort of it happened here. Whether it happens on yours, I don't know.
It's going to happen on yours. Okay. We solve the equation. What do we have to do now? We have to cross out any solutions that give us a denominator of 0. Look back. This number 3 is a mess.
Look at this problem.
Look back at that original problem.
We're either going to put a 1 in this blank or have to choose the solution is the empty set. That's another way they say no solution. Okay, so we have to mark out the number 1. We use this option B. But what's the only number that's going to give us a 0 in the denominator?
That first denominator is a 4. It's always going to be a 4. But the second denominator, it varies depending on the x value. What's the only x value that will give you a denominator of 0? A 3? Did we get a 3? So negative 1 is an acceptable solution. Then you'll follow our logic.
See?
Negative 1 does not give a denominator of 0. Does not make denominator equal 0, so it's okay.
So that one's pretty messy.
It works out nicely in the end because you don't have to solve
getting to that, I mean, look at this. That, oh wow. Just looking at the finished problem, what the heck is going on here? You know? So, any questions over that? Started with a rational equation. It looked quadratic for a moment. Turned out to be linear, so isolate the x.
if you have two distinct denominators, or if you have multiple distinct denominators, neither of which can be factored, then the least common denominator is the product of the denominators. Looking at number 4.
Y'all had to guess what the least common denominator is going to be here. What would you guess? If you have the same denominator. Oops. Keep in mind you want those denominators to cross cancel. What would cancel with the x minus 7? No. X minus 7. It's an easy answer, and it seems hard. Okay? If you just multiply straight through by x minus 7. So on this one, what we're showing is if you have the exact same denominator in the fractions, that's the thing you're going to multiply straight through by.
Okay, we said if we have multiple denominators that can't be factored, the least common denominator is the product of those denominators. If you have exactly the same denominator, then the least common denominator is that denominator.
So, they're not all as messy as number 3.
How many terms do I have total in this problem? On the left side, how many terms do I have? Just 1. Now on the right side, 1 and 2. So that's a total of 3 terms in the original problem. Each fraction is a term, and we have a constant term. So we're going to have to multiply by the least common denominator 3 times. We multiply here. I'm not going to bother putting the over 1s the way I did for the very first one. We've got the hang of it. This stuff here that we put here can only be canceled with the denominators. It's already so messy. I'm going to not bother with the over 1. So we multiply by x minus 7. And we multiply by x minus 7.
That's the common mistake. A lot of times students forget to multiply the 8. You don't just multiply the fractions. Every term. There's 3 terms. Fraction, fraction, number. Terms are separated with addition, subtraction, and equal signs.
Keep in mind a fraction is 1 term. So, what's going to cancel here in the first product? X minus 7, leaving me with equals. What's going to cancel in the second product?
7.
X minus 7 again, leaving me with
7.
Just the 7 plus what's going to cancel in the third product? Nothing. There's no fraction there. You just distribute the 8 to give you an 8x. And what else? Minus 56. I agree. 8 times x is 8x. 8 times negative 7 is a minus 56. This is nice again because there's no x squares, there are no quadratics, so we just have to combine our x terms together and then combine the things that don't have x's. Let's move that 8x over to the left by doing what? 1x minus 8x gives me negative 7x, I agree. So we have negative 7x is equal to, we have a 7 minus 56. 7 minus 56 is a negative 49. That's nice. So we've multiplied by the least common denominator. We verified every fraction canceled out. And now we're about to get our solution. Divide by negative 7 to give me x equals, what's negative 49 divided by negative 7? A positive 7. So we've done the first 3 steps. Multiply, cross cancel, solve. Last thing we have to do is make sure that the number we get doesn't give us a denominator of 0.
Let's look at the problem right here.
Look at the original problem.
What would make these denominators 0? What x value?
7. What do we get as the solution? 7. We have to cross this thing out. 7 makes denominator equals 0.
It's sort of hard to tell here, but it's so cluttered. But if you look at the problem here on Pearson, 7 minus 7. Okay. Hey, I wonder what would happen. I'm just going to try, if I punched in 7, is it going to just say wrong, or does it give you a hint? Which is great for homework if it gives you a hint, but on tests it won't give you a hint. One or more, your response. So they just tell, okay, use the parenthesis, the LCD. Yeah.
So no solution.
Oh, let me show that. Yes. Okay. Is that how they worded it, or did they say empty cell? Oh, okay. Same thing.
Any questions there? If there's just one thing appearing in the denominators, then that one thing has to be the least common denominator. If you have different denominators that can't be factored, then the product is the least common denominator. Number 5.
What if you just have x's in the denominator and exponents? Well, that's what you're going to show now.
Let me write the problem down.
Okay, so we're showing on this one what to do if you just have like x squared, if there's exponents down there. Now let's think.
You know something, before we do anything, what number would be unacceptable for x? What number, if you plug in for x, would give you something like 40 over 0 or 6 over 0? 0. I'm going to make a note right now while I'm thinking about it. X cannot possibly be 0. So if we solve this equation and we get x equals 0, we're going to have to cross it out the way we did with number 4. Suppose you have repeated factors in the denominator, but with different exponents. Here we have an x, here we have an x squared. We have the same factor, just an x, but there's different exponents. That's an x to the first, this is an x squared. So our least common denominator is going to involve an x. And a common mistake, people think of the word least common denominator and they think to themselves, I better use the least exponent. And so they try to multiply 3 by x.
If you multiply by x, are both of those fractions going to cancel denominators? But this one would cancel. But what about here? You'd only cancel one of the x's and you'd still wind up with an x down here. So what are we trying to poorly say?
You're saying it poorly. I'm not saying it because you were talking.
Oh, okay.
If you have repeated factors in the denominator, to find the least common denominator, use the larger exponent. Do you see why just x wouldn't do it? If you put just an x, are you going to cancel both of those x's down there? No, you'll still be stuck with an x in the denominator. So, square. Is that what you were saying, Tony? Mm-hmm. Yes? If you have repeated factors but with different exponents in the denominator, to find the least common denominator, you use that factor, the repeated factor, in this case it's an x, but you use the largest exponent. So let's start canceling. What's going to cancel in the first product? Leaving us with just a 6 minus here. What's going to cancel? The bottom x. So we're getting rid of an x there. So what have we got left? We have a 40 and one of the red x's. You only cancel one of the red x's, so you have one x remaining. So a minus 40x equals, what's going to cancel here? Nothing. You're just going to have a 14x squared. Tony, were there any problems like this in the homework last time for the square?
We had to move the square on the right, but I think this is a good one. We didn't see any like this.
I know, that's why I have a little check beside number 5 to do that one, okay?
Oh, okay.
So to definitely do it, even if we start running slow, I was going to do this one here because it shows you something you didn't see the last time. Well, it's quadratic. So that means we have to get a 0 on one side and then either factor or factor or quadratic formula. Remember, you want the leading coefficient, the number in front of x squared, to be positive. And I'm sure Tony would have said that. The coefficient of x squared should be positive, whether you're factoring or the quadratic formula. Make sure that number in front of the squared variable is positive. If I pick this up and move it over to the left, what's about to happen to that positive 14? It becomes negative. That's not what we want. So I'll pick up these other terms and move them to the right. So I'm going to have a 0 equals. We have a positive 14x squared. Let's move this term over. That's minus 40x is going to become a positive 40x. Let's move that 6 over. That positive 6 is about to become. Okay. And before we decide whether we want to factor or use the quadratic formula, before we make that decision, I noticed something. Every number, 0, 14, 40, and 6, they're all divisible by what number? They're even, so that means that they're divisible by 2. I'm going to divide through everything by 2. That's the same thing as multiplying by 1/2. So that's why we're able to do this. Basically, we're distributing a 1/2 across both sides of the equation. And what it's going to do is it's going to shrink down the coefficients. 0 divided by 2, well, that stays a 0. 14 divided by 2 gives me a 7x squared. What's this middle term going to be here? 40 divided by 2 is 20x. The constant term will be 3. 6 divided by 2 is 3.
So is that like the only way to continue to solve this problem? Like you have to do it by 2? Or
no, it's just going to make it easier because when factoring 14, you could have 1 times 14 or 2 times 7. 6, you could have 1 times 6 or 2 times 3. But for 7, I think there's only 2 positive integers you can multiply together to give you 7. There's only 2 positive integers you can multiply together to give you 3. So by getting rid of that common factor of 2, then that's going to make everything, all the rest of the manipulation easier. And if you don't get rid of that common factor of 2, when you're factoring, you're going to wind up with a common factor inside the parentheses. Now, if you use the quadratic formula, the simplification will just be messier.
Yeah, just bigger numbers.
Just bigger numbers, that's right.
Now, am I saying on everyone's number 5, you divide by 2?
No.
Okay? No. But if you ever notice that, oh, wait, I have nothing but even numbers here.
Divide through by 2 all the way across just to shrink the coefficients down.
So start the factoring.
Okay. That's we say 1 times 7, and for 3, the only possibility is a 1 times 3. So we have 0 equals, I'll write my 2 sets of parentheses. We'll have a 1x times a 7x. I guess it's too much to ask that that have been a positive. It's a minus. What does that mean about the signs? They're different. There'll be 1 plus and 1 minus. So we're going to have to use a 1 and a 3. That's the only possibility. So let's play around here. Where should we put the 1? Where should we get the 3? Remember, the outer and inner are going to have to subtract to give you what number? That 20? I think I see it. I think we're going to need a positive 3 here and a minus 1 there. The inner product would be 21x. What's the outer product? Okay, 21x minus 1x. Sure enough, that gives you the positive 20x. Any questions on our factoring there? If you have a common factor in the equation, dividing through certainly shrinks down the numbers and makes the factoring easier. And with the quadratic formula, it definitely makes that manipulation easier. So we set the two factors equal to 0, x plus 3 equals 0, and 7x minus 1 equals 0, to give us here x equals, what am I getting? Negative 3, I agree. Here, we have to move the 1 over to get 7x equals 1. The negative 1 becomes a positive 1. And then what do? Divide by 7 to give x equals 1/7. Now, what number did we say x couldn't be? X can't be 0. Did we get 0 as a solution? No, so both of these numbers are acceptable. Negative 3 and positive 1/7.
So negative 3 and positive negative 3, comma, 1/7. Any questions? Okay. So, let's see. Number
6.
2x minus 6 over x equals x minus 4 over 2.
I'm gonna break the routine. I'm not gonna find the least common denominator. What we have here is a proportion. We have, I guess you could say, well, each denominator is separate, can't be factored. So what would the least common denominator be in this case? If you have two distinct denominators that can't be factored, the least common denominator is the product. So it'd be a 2x. I'm not going to do that though. I want to remind you all of something else that you would have seen when working with fractions. If you have a fraction equals a fraction, that's called a proportion. And there's a method of solving proportions. This method only works when you have a fraction equals a fraction. Does anyone remember the method that I'm referring to?
Look what I'm doing.
Look at what Tony's doing with the little mouse. Looks like he's cross multiply. If you have a fraction equals a fraction, you can solve by cross multiplying rather than multiplying by the least common denominator. You'll still get the same equation and the same result. But I just wanted to point out or remind y'all of this cross multiplication. You take 2x minus 6 times 2.
We should have distributed.
I'm going to write it out. 2 times 2x minus 6 equals, and then you take the x times the x minus 4. Do I remember doing cross multiplication somewhere? If not, then you're seeing it right now. You take the numerator times the denominator on the other side equals denominator times the numerator on the other side.
And that would give you the exact same thing as if you just multiply both sides by 2x.
What are we going to have here on the left side? 4x minus 12 equals here,
X squared minus 4.
I agree, x squared minus 4x. Oh, it's quadratic. So we're going to either factor or use the quadratic formula. We're going to have to get it set equal to 0. Whether you factor or use the quadratic formula, the equation needs to be set equal to 0. You tell me, you read my mind. Do you think I'm going to get the 0 on the left side or on the right side? I'm going to get it on the left side, because if I take this x squared and I move it over, instead of that positive 1x squared, what am I going to have? A negative 1x squared. I want the leading coefficient, the number in front of the square term, to be positive. So I have 0 equals, I have an x squared. Let's move this 4x over here. Negative 4x minus 4x. What's that going to give me? Negative 8x. Be careful, they're not going to cancel out because they don't have the same sign. Negative 4 minus 4 gives us minus 8. Move the constant term over. What am I going to have? Plus 12. This is nice. It's a simple trinomial, just an x squared. That's one of those things when we were factoring during the second assignment, I made the remark, no, the third assignment, I made the remark that as we get into the messier problems, you'll be surprised how often it results into with just a simple trinomial. So the factoring isn't that messy. So now if I can't get it factored, I'd have to go to the quadratic formula, but I see the factorization here. X squared, what times what? First times first, what am I going to use? X and X. Oh. Okay, the last sign's a plus. This is nice. Okay, you're on 2 of the first sign, so minus and minus. Now 12. 1 times 12, or 2 times 6. There's another one. 3 times 4. We want the pair that adds to give us what number? 8. Which pair adds up to give you 8? 2 and 6.
The simple trinomials are simpler to factor.
Oh, so I'll give Tony credit for this. This little pattern, this little thing. When I taught factoring trinomials, oh, just think about it. You know, but I really like his little, if the last sign's a plus, then the pair of numbers you're looking for have to add the outer and inner.
That only works if this first term is positive.
But it still works for outer and inner.
Yeah.
You see,
yeah.
And so.
But I mean, the whole table would be messed up.
Yeah.
Because if this were a plus, but this were negative x squared,
that does not work.
Yeah.
That's another thing. All that factoring technique, if the leading coefficient's negative, no, it's not going to work.
On the day we did that, I said they'll assume the first coefficient he was always positive, and you'll see why later on.
Mm-hmm. Because if it weren't positive, we make sure it is positive. You
move
the terms around so that it is positive. And so, wait a minute, we have 2 different factors. X minus 2 equals 0 says x equals 2. X minus 6 equals 0 says x equals 6.
And you forgot to ask
I forgot to ask y'all right off.
What would make the denominator?
That denominator here is going to be a 2. It's never going to be 0. What number would make this denominator 0? It should be obvious. 0, if you plug in a 0 for x, you get a negative 6 over 0. So x can't equal 0. Did we get 0 as the solution? No, so 2 and 6 have to work.
2 and 6. 2, 6. Okay. Any questions?
one more equation with fractions. And
Then you'll start the ones with the square roots
Then we'll
and the
start
cube
the
roots.
messy ones, okay? We have one more with the fractions, and then we're going to start the messy ones.
Okay. Okay, you're laughing. That's sort of a joke. They're not any worse than these. In fact, some of those cube root ones are real easy. It's the square root ones that are a little bit messy.
Watch how I'm writing this problem out, okay? I know. Don't write it down until you see how I'm writing. I'm not through. Oh, there. Now switch it over. There. Look at what I've done. I've separated the terms. How many terms appear in this equation? 3. Each fraction is a term, and that constant right there is a term.
What'll make the denominators 0? Go ahead and write it out in red.
I'm going to.
X can't be what?
Okay, you don't want x minus 2 to be 0, so x cannot equal 2. So once we're through, if we get x equals 2, we have to cross it out. What's the least common denominator? This is pretty nice. We have the same denominator appearing twice. So if you have exactly the same denominator, what's the least common denominator? Okay, just whatever that denominator is, x minus 2. So we're going to multiply by x minus 2. We're going to multiply by x minus 2. And we're going to multiply by x minus 2. This doesn't look that bad. What's going to cancel in the first product? So x minus 2's leaving us just 2x equals the second product. What's going to cancel? Nothing. There's no fraction, so you just distribute. Distribute to get 5x. I couldn't hear you. Minus 10, I agree. Plus, that plus is the plus right there. The third product, what's going to cancel? The x minus 2's. What's that going to leave us with? The 4x squared. Any questions there? Okay, you're going to have to read my mind again. Where do you think it's quadratic, so we've got to get it set equal to 0. Where do you think we'll get the 0? On the left side or the right side? Where do you think I'm going to get the 0? On the left side or the right side? I'm going to get it on the left. I want to leave that 4x squared on the right because I want it to stay a positive 4, not a negative 4. So we have 0 equals, I'm going to write it in descending order. Get it in standard form. We have the 4x squared. We have to move that 2x over and combine it with that 5x. What are we going to do to that 2x to move it over? So we're going to minus, so 5x minus 2x gives me 3x. Do y'all follow my logic? 5x minus 2x gives me a 3x. What else do I have stuck on here? At minus 10. Oh, well.
Like if this 3 had been any even number,
30.
Divide by
30,
2.
I'd divide 3 by 2, but they're not all even, so we're just stuck with 4x squared plus 3x minus 10 equals 0. Okay, for 4x squared, let's see about, I should have mentioned this is going to be my approach. If I run into a quadratic equation that I have to solve, I'm going to try to factor it first, okay? If I can get it factored pretty quickly, great. If I can't get it factored, or if I just don't see the factorization, I'll go to the quadratic
Suppose
formula.
it would have been 41x squared plus 30x minus 10. Oh, just go to the quadratic
Yeah,
form.
if it's numbers that are really messy, I'm just going to go to the quadratic formula automatically. But this one here, I don't think it's that bad because for 4, you can have a 1 times 4 or a 2 times 2. For 10, you can have a 1 times 10 or a 2 times 5. I know the 2x and 2x cannot possibly work. Look at this pair here. Both pairs have an even number. So if you use 2x and 2x, you'd have to pair the 10 with the 2. You can't have even numbers inside the parentheses, 2 even numbers. So I think I could discard that 2 and 2. Look here. If you tried to use 2x and 2x, right there, that 2 would be paired with the 2x. So I can discard the possibility of the 2 and 2. So let's write my parentheses. We're going to have to use the 1x times 4x. Before we go on, any questions on our logic, on my logic, why I discarded the 2?
Right here. Write out.
Write it out. Good idea. Here's my scratch work, okay?
This is why he's discarding the 2 and 2.
2x and 2x.
Well,
okay, 2x and 2x. Let's try to put a 1 into 10. Even, both numbers are even, that can't be right. Suppose you tried 2x and 2x and tried 2 and 5.
You can't put the 2 in either one of those.
You put that 2 there, they're both even numbers.
If you move the 2 over here, you still have
a 2 and 2. So that's what I was trying to say.
And that goes with like any of the same numbers in the
parentheses.
parentheses.
Yes.
Except for like 1 or.
Right. All they can have in common is 1. The only common factor is 1.
Mm-hmm.
Oh,
yeah, if 10 hadn't been an even number, if it had been a
9, then we would have to test both. It could be 2 and 2. Because the fact that that number is even, this number is even. Well, for 2 and 2, both of those numbers are even.
Mm-hmm.
Now let's stop and think before we write down. What do you want to try? The 1 and 10 or 2 and 5? I think the 1 and 10 is going to throw us way off from the 3x that we need. That number's sort of small. Choose the numbers. Well, you say they subtract to give you a 3. That's just a coincidence. Okay? But I can see if you put the 10 there, you're getting a 40. If you put the 1 there and the 10 there, you're going to have a 10 minus 4. That's not giving you the 3. So we better try the 2 and the 5. Can I put the 2 here? No. I have to put the 2 here and the 5 here. And what do we say about the signs?
I don't think we said it.
I don't know. You're right. I don't think we did. Okay. That last sign's a minus, so we're going to have a plus and a minus. They'll be different. Play it out in your head. What should go right there between the x and the 2 to get a plus 3x?
Plus?
A plus, I agree. A plus there, which means a minus there. The outer product is a negative 5x. Here's my scratch work checking. The inner product now is a positive 3x, not positive 3, 8x. Negative 5 plus 8 gives me a positive 3x, which is what I needed. And we've been lucky so far. The things that we've had to factor are things that I could see in my head pretty quickly, okay? But
most of them, there's just one problem in this assignment that regularly gives big numbers.
yes,
And when we get to that one, we're going to use the quadratic
quadratic
form.
formula. So this first one, set an x plus 2 equal to 0. That gives us x equals negative 2. I agree. This one says 4x is equal to positive 5. So divide by 4 to get x equals 5 over 4. Are both of these numbers acceptable? 5/4 and -2. What's the only number we said we couldn't use as a solution? +2. Did we get a +2? No, we got a -2, so that's perfectly fine. There and there.
-2 and 5/4. -2, comma, 5/4. Okay. We're switching from equations with fractions. The next one's going to be an equation with a square root symbol, and that's called a radical symbol. Okay?
So we're starting the second type of special equations, radical equations. What we're going to do is we're going to go through, just like with fractional equations, we do something to remove fractions so that we can solve the equation using our traditional methods. With radical equations, we're going to do something to remove the radicals, so we'll hopefully wind up with a quadratic equation that we can either factor or use the quadratic formula on, okay? But there's something we need to discuss regarding radicals before I write up my little general procedure for solving radical equations. Suppose we had, let's say, the square root of x, and we were to square it. I remember this popping up early on during the first assignment. If we have a square root that's being squared, what impact does that square have on the square root? That cancels it out. Just need to move the radicand, say an x. And if you had something like, let's say the square root of, let's not say a square root, let's say a cube root. We have the cube root of x, and it was being cubed. A cube root being cubed, that exponent cancels out the radical. So once again, we're just up at the radicand x. In general, for an nth root, if you have something like the nth root of x, where x is any counting number, whether it's a square root, cube root, fourth root, for n is any counting number. And I think we're going to see cube roots and fourth roots in this assignment also. To get rid of that radical, you would need a power equal to that little number there. Whatever that number there is called the index. For example, this index is a 3. That's a cube root. There's no index there, so it's assumed to be a 2, a square root. But if we have a nth root raised to the nth power, then you're left with just what's underneath the radical. When we look at inverse functions in about 6 weeks or so, we'll be saying that these things are inverses of each other. So they cancel each other out when performed consecutively. The power and the nth root.
That's just any number.
Yes, and it doesn't matter what's underneath the radical, okay? You don't have to have just one term. If you had something like the square root of 2x plus 7 all being squared. If you have the square root of 2x plus 7 being squared, that square will cancel out that radical, leaving you the thing under the radical, the radicand, just a 2x plus 7.
Give them the sequences. Or your suggestion.
But before we do that, I have one other thing I want to do. Look at this. Suppose we had the square root of 2x, and then we have the plus 7 not under the radical. Suppose we tried to square that. As long as everything is under the radical, that square will cancel out that square root. They're performed consecutively, they cancel each other out. Suppose the plus 7 had not been under the square root. At that point, we have a sum being squared. How do you square a sum? You don't just square the first term and square the last term. I remember when we had a complex number in assignment number 2, 3 plus 2i, and it was being squared. What do we have to do? To square a sum, you have to...
It's one of those F words.
You write it twice, and then you FOIL it out. Don't write this down.
Don't write that.
What I'm about to do. I'm not going to go through and solve it. I just want you to see. I guess you could write this part down. Okay, you'd have to write it twice, and then you'd start FOILing. I'm not going to go through the whole thing, but I want to make a point. The square root of 2x times the square root of 2x, that's the square root of 2x squared, so that's just a 2x. Out of the square root of 2x times 7 is the square root disappearing. First times first, the square root disappeared. But what about right here? The square root of 2x times 7, that's just 7 square roots of 2x. The square root disappeared. No, it didn't. My point is, just raising a radical to a power doesn't guarantee that you're going to get rid of the radical. Before you can raise a radical to a power, you need to make sure that the radical term is isolated. This is what you don't want. You don't want a square root with a plus something or a minus something. Before raising both sides of it, raising a radical to a power, you must first isolate a radical term.
So we're going to come across these in this assignment?
No, not if you do it correctly, you're not. You may have, if I'd had a plus 7 there, I would have moved that thing over to get the radical isolated. So,
just first isolate.
Okay, so first isolate a radical term. There may be more than one radical term, but before you start trying to raise both sides of an equation to a power, to remove fractions, we multiply both sides of an equation by the least common denominator. To remove a radical, whatever the index on the radical is, that's the power you're going to put on both sides.
I'm afraid they're losing the big picture, Tim.
To solve
this one, wait, I've switched the screen. He's saying the first thing you got to do is isolate the radical term. Like on this number 8, what are we going to do first? How would we get that radical by itself?
Take minus that.
Well, you could, but then you have a negative in front of that radical. I would move the square root over to the right, which is what he's going to do when he actually starts working on it. Okay?
To solve a radical equation, the first thing, this isn't that bad, so don't start panicking. To solve a radical equation, I should have just started with an example rather than this generic talking that I'm doing. Okay, to solve a radical equation, the first thing you're going to do, you're going to make sure that at least one of the radicals is isolated. I'll say, isolate a radical term. If there's more than one, get one of the radicals by itself. Isolate a radical term. And then you'll raise both sides of the equation to the power of the index. If it's a square root, you're going to have to square both sides. If it's a cube root, you're going to have to cube both sides. If it's a fourth root, and there is one with a fourth root, you're going to have to raise both sides to the fourth power. So I'll say, raise both sides to the power of the index.
And maybe beside index, put root in parentheses.
Okay.
If it's a square root, you square it. If it's a cube root, you cube it. Okay, the index is just another name for the root.
If you do this correctly, you should come up with an equation that's either linear or quadratic, and you can solve it using the traditional methods that we've seen. So at this point, solve. Step number 4, there's a problem. This wonderful method that we have of solving equations by eliminating radicals, there is a drawback. Raising both sides of an equation to an even power does not guarantee equivalence. Just because we squared both sides of an equation or raised it to a fourth power and got rid of the radicals, that doesn't guarantee that the solutions you're getting are solutions in the original problem. Think about this. I think y'all will agree. As long as I have that even exponent, this thing's dead. Do y'all agree with this statement? Look at my scratch word. Do y'all agree that negative 3 squared is the same thing as positive 3 squared? Negative 3 times negative 3 is positive 9. Positive 3 times positive 3 is positive 9. So as long as you have that little square there, it's a true statement, correct? Suppose you didn't have that square there. Let's back up. Suppose you didn't have that square there. Is it still a true statement? No, it isn't. When you raise both sides of an equation to an even power, you run into the possibility of taking something that started off negative, but when you square a negative, what does it become? Positive. Cube roots get a bad rap. People don't like cube roots, and they're so much nicer. Cubing doesn't change signs. You take a negative number and cube it, it stays negative. You take a positive number and cube it, it stays positive. The signs aren't changing. It's those even exponents that cause all the problems, because even exponents take negative quantities and change them to positive. So we may inadvertently be going along squaring both sides and accidentally change a negative quantity to a positive quantity. So in the 4th step, you're going to have to check your solutions for even roots.
So if you have a square root or a fourth root, it's
Okay.
mainly the square
Roots, that's what we have most of the time. A 4th root, you'd have to check your solution. 6th root. What about the cube roots that we're going to be seeing? Are we going to have to check those answers? No, that's one of the reasons people don't like cube roots, and they're so much nicer than square roots. If you think about it, it's those square roots that cause us to have those imaginary numbers. It's perfectly fine. The cube root of a negative 27 is a negative 3. So cube roots don't create imaginary numbers. It's those square roots and 4th roots and 6th
Okay,
roots.
let's write down this problem and get going.
Okay, here we go. Number 8. We have x minus the square root of 27 minus 6x equals 0. Okay. First step, we have to isolate a radical term. The only radical term we have is this one here, so we've got to get it by itself. Well, the smart thing to do is to pick up that square root, move it over. That negative will become a positive, so we're just going to have x equals a positive square root of 27 minus 6x.
You just said square root, so
It's a square root, So we're going to have to square both sides. Let me ask you something. When we're through, are we going to have to check our answers? Yes, we are. So we're going to square both sides, and x equals, I'm going to rewrite this. You'll see why in a moment, or once we're through. I'm going to square and square. The left side reduces very nicely. What have we got on the left side? Just x squared, I agree. Equals, hey, the right side's reducing pretty nice too. Everything's under the square root. So, okay, that's square and does the effect of the square root, leaving us just a 27 minus 6x. It's quadratic. That means we're going to have to get one side set equal to 0. Where do you think I'll get the 0? On the left side or the right side? On the right side. I don't want to pick up this x squared and move it over here, because that positive 1x squared, if you move it over, it's going to become, okay, so we'll leave the x squared on the left. Let's write it in standard form. We have x squared, move over the x term, that's going to give me a plus 6x, and minus 27 equals 0. Hey, we're ready for step 3, solve the equation. It's a simple trinomial. As I said, frequently, when you're going through the messier problems, the trinomial will result in a simple trinomial. So that's nice. X squared, that's just x times x. Oh, and you're wondering, how do I even know that they're factorable? Did you mention this, Tony? If it's not factorable, they're pretty good at saying solve using the quadratic formula. This textbook author's not going to force you to sit there for 30 minutes going through trying to factor something that's not factorable. If it says use the quadratic formula, it's probably not factorable. The fact that the instructions didn't say use the quadratic formula, I'm pretty certain that it's factorable. X squared, that's just an x and an x. What do we know about the signs? And second sign's a minus, so we're going to have different signs. Now for 27, we have a 1 times 27 or 3 times 9. For a simple trinomial, it's simple to choose the pair. You want the pair that subtracts to give you that 6. 3 and 9. 9 minus 3. So I'll put the 3 there, the 9 there. Play it out in your head. Remember, you want a positive 6x. So what needs to go in front of that 3? A plus or a minus to get back that plus 6x. A minus here and a plus there. I agree. The outer product. What's the outer product? A 9x. There's my scratch paper. What's the inner product?
Minus 3x.
9x minus 3x. That gives me a positive 6x. Is that what I needed? Yes. So, set each factor equal to 0 to give us x equals 3 or x equals negative 9. Any questions up to this point?
Isolate a radical, square both sides.
Solve the equation. We're through with step 3. All we have to do is check our solutions. Okay, my advice to you for checking, always use the form where the radical is isolated. I'm not going to plug into this original thing here. With the fractions, it was easier. With the fractions, you just made sure the number you got doesn't give you a denominator of 0. Here, it's a little more rigorous, but it'll be easier if you use the isolated form. That's why I rewrote it before I set the squares on it. This is what I'm going to use. The isolated form, that's what I'm going to use for checking.
And he's going to actually plug in the number 3.
To see, does the left side equal the right side? I'm using x equals the square root of 27 minus 6x. If you view an example, they probably use the original form for checking. It is easier to check if you use the isolated form. Plug in 3. We get 3 equals the square root of 27 minus 6 times 3. 6 times 3 is going to give me what? 18. 27 minus 18 is 9. So we have the square root of 9 on the right-hand side. Is this a true statement? Does 3? Yes, it does. 3 equals 3. So 3 is an acceptable solution.
You circled x equals, but you're only going to
Oh, you're only typing
the
in the 3. Be careful. You only type in 3 is the solution. Okay, that's the first solution. Now let's check this negative 9. Let's check the negative 9. X equals the square root of 27 minus 6x. We plug the negative 9 in here for x. Are y'all following me? I'm plugging in negative 9 equals, and I start to write the square root and I'm going to stop. This cannot be right. This cannot check without even plugging in the negative 9. We have a negative 9 on the left equals, I don't see a sign in front of that square root. If you don't see a sign, what sign do you assume is there? A positive. Can a negative number equal a positive number? No. That's why using the isolated form is easier. If you have the isolated form, right off you can tell. And this is going to be important because sometimes you're going to have to be plugging in fractions. Some of these answers will be fractions. I sure don't want to have to plug in a negative 1/7 here and here. But if you use this little trick of mine, as soon as you see it's negative on one side, it has to be positive on the other. Do y'all follow what I'm saying? We plugged in the negative 9 for x, so the left side is negative. This side here, there's no sign, so you assume it's positive. A negative cannot equal a positive. So we discard negative 9. The only solution is 3. Any questions there?
I feel like you're about to say something else. Samuel definitely personifies fate.
That's right.
If you ever saw the original Halloween movie, the boring teacher up there is saying, that's right, Samuel
definitely personifies fate.
And it sounded like that's what you were saying.
Was it?
Or something in that tone.
Now, this is going to be fun. We're going to do number 9 now. Traditionally, number 9 is the messiest homework problem of the semester. Okay? So,
Tim, in the previous life, we were both motivational speakers, okay? But traditionally, number 9.
But if you think about it, it is pretty good because I'm saying right now, in my opinion, this number 9, unless it's different from every other number 9 that I've ever done in this course, and look at those numbers. Yeah, it's going to get messy. I can just tell looking at it. Okay, number 9. Square root. What power am I going to raise both sides to? A cube root? A cube or a square or what? A square, because it's a square root. Okay. Move it down. And
there's not a lot of assignments during the semester where we're like, oh gosh, it's that day.
I don't know why I got stuck because I was absent on Monday. Right?
You did it the last time, so
you know you're faster.
Yeah, well,
okay, but we're in no hurry. We have 2 hours and 50 minutes.
Oh.
So the first thing we got to do,
Well,
isolate a
nearly
radical term. Isolate a radical term.
Only one correct first
First
step.
step.
If you don't do this first, whatever else you're doing is wrong.
What do you think we should? What do you think I'm going to do?
Add the 4.
Get that at the square root by itself. So I'm going to add 4.
Earlier, when it all started sort of being a mess, Tim, or your general talk was going downhill, that's what he was trying to get at right here. If you squared without without isolating, you're going to wind up having this huge mess that you got to FOIL, and you're still going to have a square root in it.
You've got to, before you raise both sides to power, you must isolate a square root and a radical. In this case, there's only one radical. So we have the square root of 5x plus 9 equals, we'll have a 2x, negative 13 plus 4 is a minus 9. And now we're ready to do what? We have the radical isolated, so...
So why do we? Oh, because it's the opposite.
Why is there a plus 4?
the minus 4 becomes a plus 4.
You're adding 4 to both sides.
Moving it over, negative 13 plus 4 gives me that minus 9.
And the square root symbol.
Am I answering your question?
No, I was talking about, because you said we're gonna square the square root, or we're gonna
square both sides. Write the squares right up there.
But then
Okay, but this is the format that I'm going to use. This is the thing I'm going to use to check. So I'm going to say, use this equation right here to check. So we have the square root of 5x plus 9.
It's just
and we're going to square it.
And squaring.
Equals 2x minus 9 squared. Squaring the left side is very easy because we isolated the square root. What's the left side going to reduce to?
5x.
Just the 5x plus 9, the thing under the radical. Uh-oh. We're going to have to square 2x minus 9. How do you square a sum or difference? It's not just 4x squared plus 81. What are we going to have to do? Foil it out. So by isolating the radical, we're not having to FOIL with square roots, but you're still going to have to FOIL. I think I'm going to write it out right here. I'm going to repeat it. 2x minus 9 times 2x minus 9. Let's start FOILing. First, 2x times 2x, that's a 4x squared. Outer, 2x times a negative 9 is?
Negative.
Minus 18.
Okay, minus 18x. What about the inner? Negative 9 times 2x.
Minus 18.
Another minus 18x. What about negative 9 times negative 9?
Positive 81.
Positive 81. So it's quadratic. We have that x squared term. So we need to get it set equal to 0. Where do you think I'm going to get the 0? On the left side or the right side? I'm going to get the 0 on the left side. I want to leave that 4x squared where it is because I don't want to move it over and make it a negative 4. So 0 equals, we have 4x squared. Negative 18x minus 18x. Here's my scratch paper. That's a negative 36x. What am I going to have to do with that 5x? They can't see my scratch work. There. Okay, we subtract it. So negative 36x minus 5x, that's going to give me a negative 41x. I'm already thinking this might be a good problem to use the quadratic formula on.
Yeah, that's what I was.
We have an 81 minus 9, what's that going to give me? Positive 72. Negative 18 minus 18 is negative 36. I subtracted 5. That gave me the negative 41. We had an 81. Subtract 9. 81 minus 9 gave me a positive 72. Any questions there?
If you were going to factor it, you can use that little rule. Since 72 is even,
there's no way you could use 2x and 2x.
So this one actually doesn't work out nearly as bad. The numbers aren't nearly as large as they've been in the past. But we're not going to factor it. I want to demonstrate using the quadratic formula on something with big numbers like that.
I'm correct in saying y'all did none of the problems y'all did with the quadratic formula had numbers this big, correct? Okay, so let's assign A, B, and C. A is equal to 4. B is negative 41. What's C? 72, just seeing if you're awake. So we know the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a Okay, so first of all, negative b, the opposite of b, the opposite of negative 41 is, okay, so we have 41 plus or minus the square root, dig out that calculator. Okay, b squared, that's a negative 41 times a negative 41. That's going to have what sign? Negative times negative is going to be positive. So look at what Tony did. He just wrote 41 squared.
Make sure if you're using a calculator, and who wouldn't be using a calculator on this, you don't do that. If you're squaring a negative number
on your calculator, you better enclose that number in parentheses. The easy thing to do is just remember b squared is always going to be positive. Because whether b is positive or negative, when you square it, you'll get a positive result. 41 times 41 is 1681. And then to divide minus 4.
Minus 4, parentheses.
Minus 4. Parentheses. I want to do this the way Tony was doing it on Monday. Yeah. So A is 4. And C is 72.
Remember, I'd punch it into the calculator, what's under here, and the last time, well, the numbers were so small. You sort of begin to see maybe based on this why I was using a calculator. Because if the numbers are really large, I don't think anyone in here wants to do this by hand. So it's possible, of course.
Sure, of course.
What's on the bottom? 2 times A.
What's my denominator going to be? 8. I agree.
So let's simplify under that square root.
So we have 41 plus or minus the square root of
1681 minus 4.
Make the calculator bigger now, so it's easier for the students to see it. It's easier for me to see it also there. Minus 4.
Parentheses 4. Parentheses 72.
529. That's a perfect square.
So that's a nice. All over 8. But let's go to see what's.
Any questions on how we got the b squared minus 4ac to equal 529? Okay. The square root of 529. There it is. The square root of 529 is 23. Now, this didn't happen for any of y'all's square root problems the last time. if the b squared minus 4ac turns out to be a perfect square, that means the equation was factorable. And it was factorable. They didn't tell us to use the quadratic formula, which meant it was factorable. And I actually saw the factorization before.
But I wanted them to see if you're doing the quadratic formula and it's something that can be factored.
Now, when you were using the quadratic formula the last time, you'd have a number plus minus a square root over here, but we don't have any square roots remaining. Our solutions will be rational numbers. You're going to have to break it into two possibilities. This is what's different about the last time. The last time, you didn't wind up with the perfect square under the radical. You have two possibilities now. 41 plus 23 over 8. So separate it out. 41 plus 23 over 8. And 41 minus 23 all over 8. You have two possibilities. I'm separating them out.
You agree if we had solved this with factoring, you would have wound up with two numbers. No square roots. It'd either be an integer or a fraction. So let's see on this one.
41 plus 23, that's 64. All over 8. So there's the first number that we think our solution is 8. 8 may not check, but that's the first solution we're picking up. Now, what's 41 minus 23? Is that 18? So we have an 18 over 8. I should have written x equals and x equals. 8 doesn't divide evenly into 18, but there's a common factor of what? 18 over 8, both of those have a common factor of 2. 18 divided by 2 is 9. 8 divided by 2 is 4. So we've come up with two possible solutions, 8 and 9/4. Any questions on our logic up to this point? So we would have used x minus 8 and a 4x minus 9 in the factorization. One of the easy ones to factor, actually. Let's check. And remember, we're checking where the radical is isolated. That's the easy spot to check. So we're plugging it into the square root of 5x plus 9 is equal to 2x minus 9.
Is that going to check?
I think it is.
8 in.
Plug in the 8. 5 times 8 is 40. So you have the square root of, I'm going to move up now, you have the square root of 40 plus 9, and 40 plus 9 is 49, and the square root of 49 is 7. Are we going to get a 7 over here? 2 times 8, we're plugging in 8, 2 times 8 is 16 minus 9 gives me 7 equals 7, yes. So 8 checks. 8 checks. Now we got to plug in 9/4. Okay. Plugging in 9/4.
Oh.
For square root equations, if you solve enough of these things, like I have over the past 37 years
of teaching, that doesn't count doing them as students.
Yeah.
So, okay.
Well, you get to a point where you just get a feeling, I don't think 9/4 is going to check. Let's try that trick. I don't see a sign there, so what side does the left side have to be? It's going to have to be positive, right?
No.
plug in 9/4.
I'm going to do it with my calculator.
Times 9/4 minus 9. 2 times 9/4 minus 9. 18/4, that's 9/2 minus 9. This thing's going to be negative. Can a positive number equal a negative number? No. Any questions on our logic, how we check that? You can plug in the 5/9 there. No, the 9/4 yourself, multiply by 5, add 9, and take the square root. You'll get a positive number, and it wouldn't equal that negative number on the right. But the point of this is the most common for a square root equation. For a square root equation, when you have two possible solutions, the most common scenario is one of them checks, one of them doesn't. It's not hard to rig it so that both of them check, but I'll tell you what is difficult. It is extremely difficult to rig a square root equation where you get two possible numbers, neither of them check.
If you find yourself doing that,
If you have a square root equation and you have two possible solutions, odds favor one will check and one will not check. And that's something you might want to remember. All of that just to get the answer x equals 8.
oh, let me plug that in. Ooh, move this. 8.
Okay, that's the worst one this semester. So.
We've done the 2 worst problems this semester.
What was the other one?
That rational one?
Oh, I see.
Uh-huh.
Mm-hmm.
Okay, so.
Switch back so they can see the answer.
Oh, okay.
So the answer is x equals 8.
Yeah.
Well, just 8.
Try to get it where you can.
Well, this thing is down too low. I must have hit it there.
Oh, wait, it's
Still not high enough. Uh-oh. Watch me mess it up and we go out of focus.
No, I'll bring you the focus.
There.
Are you going to leave it like that?
Yeah.
Okay, I'll focus it. Okay. Yeah, arguably the worst problem this semester. Okay, well, I don't know if you're one of those
So
people
you're ending the third week and you're able to think to yourself, at least
the worst is behind me.
well,
I mean,
once
you
you've
still
done
fail.
this assignment and then done the review and taken the test and stuff, but
Let's do
this
number
problem
11.
here.
Let's move on. Let's do number 11. Number 10 is another very,
A square root one that's not so messy. Okay?
and it's worked in the first video, but number 11. I guess I should have mentioned this earlier. Monday will be a lighter assignment. Okay?
It will be a much easier assignment. If you doubt it, you just
wait till Monday. Monday will be easier. Okay? They're not all going to be this heavy. This is one of the heavier assignments.
by heavier he means difficult.
Yeah, I didn't want to say that word.
Now that's what you mean.
Oh, yeah.
Okay. Y'all remember my little general steps for solving a radical equation?
What should he do?
Okay.
Isolate
the radical. One of these steps I'm going to skip. Which step will I skip? Step 1, 2, 3, or 4? Look at the type of radical we have.
Oh, the last one.
Yeah, you don't have to check it.
You don't have to check it if it's an odd radical, only even roots, okay? Cube roots, fifth roots, you're not going to have to check. So, first step, isolate the radical. So we have the cube root of 3x plus 9 is equal to, what are we going to have over here? -4. 1 minus 5 is a -4. Now we're going to raise both sides to the index power. So instead of squaring both sides, we're going to cube both sides. The left side reduces very nicely. The cube root of 3x plus 9 cubed is going to reduce to 3x plus 9.
Yeah, the cube root and the cube cancel out. Don't say negative 12. What's negative 4 times negative 4 times negative 4? In order to enter an exponent other than square on this calculator, I have to hit the little caret top. Negative 4 times negative 4 times negative 4 is negative 64.
Am I going to have to get it set equal to 0 and factor?
Do we have a quadratic or a linear equation?
I think this is the easiest equation we've had so far in this assignment. Let's move the 9 over by doing what? Okay. So we have 3x equals negative 64 minus 9 gives me a negative 73. And then divide by 3 to give us x equals negative 73 thirds. And look at what I'm doing. There's the answer.
Don't have to check it because it's an odd root. Interestingly enough, on View an Example, they say check it for everything. But you don't have to check odd roots, only even roots.
I'm going to make a note here.
Oh.
I'm going to write odd, so don't check. You only have to check you can check it if you want to, but you only have to check the ones that are the even indices. When you square both sides, raise both sides to the 4th power.
Okay. Going quickly now. We're going to do 2 more, problem 12 and problem 14. So just bear with us.
Number 12.
This one has 2 cube roots. It looks hard. I mean, it has 2 cube roots. I bet this is the hardest one so far. And no, it isn't. It's really only...
A cube root of 2x squared plus 6x minus 6 minus the cube root of 7x equals 0. We have to isolate a radical. In this case, there are 2 radicals. But if we're smart, we could isolate both of those radicals in one single step. What do y'all think I'm going to do?
Before you cube it.
But we can't cube it until you can only have a single radical by itself on one side before you start raising to a power.
At the 7x.
Okay, take that radical, move it over to the right. That minus will become a positive. Look how nice this equation looks now. You have the cube root of 2x squared plus 6x minus 6 is equal to the cube root of 7x. We picked that up, we moved it over, the negative became positive. Before raising both sides of an equation to a power, you must first isolate a radical. In this case, we were able to isolate both of them in a single step. Now, we'll cube both sides.
And I guess it looks like you've just dropped the radical sign.
And well, that's what's going to happen. Everything here is under the radical, so when you cube it, it all disappears, and you're just left with the radicand 2x squared plus 6x minus 6. You tell me what we're going to have on the right side.
7x.
Just the 7x. Oh, it's quadratic. Whether we solve by factoring or the quadratic formula, we'll need the thing set equal to 0. Where do you think I'm going to get the 0? Do you think I'll get the 0 on the left or on the right? On the right. I want that 2x squared to stay at positive 2x squared. So we have 2x squared. We have a 7x. What are we going to have to do to this? I mean, a 6x. What are we going to have to do here? 6x minus 7x gives us a minus 1x. We still have the minus 6 equals 0.
Are we going to have to check this one?
No. Factor or quadratic formula? What do y'all want to use? Factor. I think that for 2x squared, there's only one possibility, 1x times 2x. So I agree that factoring shouldn't be too bad. 1x times 2x. For 6, there are two possibilities. 1 times 6 or 2 times 3. Oh, that looks funny. This is an arrow, arrowhead. It looks funny. Do all my arrowheads look that funny? Okay. Which one do you want to try? 1 and 6 or 2 and 3? 2 and 3. If we're going to try 2 and 3, can I put the 2 here? No, because then we'll have a common factor of 2. So if we're going to try 2 and 3, we'll put the 3 there and the 2 there. I forgot to ask y'all what we know about the signs. Okay, that last sign's a minus, so we're going to have
Plus minus.
two different signs, plus and a minus. Play it out in your head. You want the outer and the inner to give you that minus 1x. Should I put a plus here or a minus here? A plus? I'm thinking it's a minus. Let's see if we put the plus there and the minus there. Let's check. What's the outer product? X times a negative 3, that's a negative 3x. What's the inner product? That's a positive 4x. Is that giving us back what we need? Negative 3 plus 4 gives us a positive 1x. Is that what we needed?
No.
No, so switch the signs. That should be the minus. There's the plus.
I think that's what you used to do before my weight.
Yeah, I always filled in automatically. The first set of parentheses got a plus. The second got a minus. If I was wrong by a sign, then I'd reverse the sign. So set x minus 2 equal to 0 to give us x equals 2. Set 2x plus 3 equal to 0. That says 2x is equal to negative 3. And then?
X equals negative 3 over 2.
Okay, so divide by 2 to give x equals negative 3 over 2. And that was all, so we don't need to check our answers. I'm 100% confident that 2 and negative 3 halves will both check. Any questions there?
See, they're not all as bad as some. I mean,
yeah,
I'm
afraid what I'm saying is 2 and
Oh.
negative 3 halves. I'm afraid at this point everything I'm saying is just hitting you in the face and bouncing
the
off.
first video up there has every problem done, but we want to do one more.
Number 14. Write it down.
First glance, this doesn't look anything like the other problems. Okay? There's not a little radical symbol. There's no root, is there?
X plus 5 to the 1/3 minus 6x. Okay.
Oh, this is such a good problem. I don't remember, in the past I used to always have this one as a test problem. It just looks hard.
Okay, switch over.
Well, why is this problem with an assignment? It should be something with square roots and cube roots and fourth roots.
I don't even see a radical here, so how did it get stuck there? What I see that looks bizarre, these exponents. A fractional exponent? what does a fractional exponent mean? An exponent of 7 means you multiply the same thing 7 times. An exponent of 3 means you multiply the same thing 3 times. But 1/3 is not a counting number. You can't say we're going to multiply this stuff 1/3 times. For a rational exponent,
remember, rational means fraction. So if you have an exponent, that's a fraction.
maybe I should write out fractional exponent. Why am I being fancy at this point, okay? I'm going to write out fractional exponent. A fractional exponent is the same thing as a radical. A fractional exponent is the same thing as a radical. Okay, I'm going to start with an exponent of 1/2, okay? A to the 1/2 is defined to be just the square root of A. If that had been an exponent of 1/2, then you'd be looking at the square root of that quantity. An exponent of 1/3, that's the same thing as, a cube root. Oh goodness. A to the 1/3 is the same thing as the cube root of A. And in general, A to the 1/n, A for anything. Anything to the 1/n power is the same thing as the nth root of A.
A 1/4 exponent is a 4th root. A 1/5 exponent, a 5th root, and so forth.
But an exponent of 1/3 is the same thing as a cube root. So instead of 4x plus 5 to the 1/3, write it as a cube root of 4x plus 5. Minus, instead of that 6x minus 1 to the 1/3, write it as a cube root of 6x minus 1.
Now, is it similar to number 12?
Yes, it is. It's easier than number 12, actually, because we have this cube root minus a cube root equals 0. What power are we going to have to raise both sides to? 3, because it's a cube root. Can we start cubing both sides now? There's only one smart first step. What is it?
Yes.
Move that over, because the negative, when you move it over, it becomes a positive, and you've isolated both of the radicals then. So you have the cube root of 4x plus 5 is equal to the cube root of 6x minus 1. And now we're ready to cube both sides.
Is this cubing going to work out nicely?
So it's going to be a nice equation to solve or a messy one. Nice, because what's the left side going to reduce to? 4x plus 5, I agree. And the right? Okay, 6x minus 1. Are we going to have to get it set equal to 0 and try to factor? No, it's a linear equation. So let's group our x terms together on one side and our constants together on the other side. What do y'all want to do? I'll let y'all tell me what you want to do. There's really no wrong way to approach it.
Either put all the x's on the left or put all the x's on the right, whichever one
minimize the number of negatives. People mess up with more negatives. Let's move the 4x over to the right. So we subtract 4x, and what's that going to give us? Right here. 2x. Let's move this constant over by doing what? Adding the 1. What's that going to give us? Well, 2x equals 6, and then?
X equals 3.
Okay, good. Give us x equals 3. Do we need to check our work? No, it's an odd index. Remember, the reason you get those solutions that have to be marked out is because when you're changing signs, you're taking a negative quantity raising it to an even power, and it gives you a positive quantity. Here, you're not raising it to an even power, it's an odd power, so you can check your solution if you want to here, but it has to work. Any questions there?
Not every assignment going forward is going to be this.
The next assignment is one of the shortest, easiest assignments of the semester. So
Monday. And we've also been looking at.
Yeah. Did you type in 3?
Yes. We're thinking that on where's that calendar? Here's my low-tech calendar. Oh, here it is. We're thinking on February 21st. That'll be a day where if you have a Chromebook and you're not using
you're not taking your quizzes and tests at home. It looks like this is for February 2024. If you're watching this video in a year's time, that doesn't apply to you. This is for our class right now in February 2024. It looks like Wednesday, February the 21st will be our first Chromebook testing.
And if you're watching this video and you're in the online class, then no.
That doesn't apply to you. This is for the face-to-face class. Those of you that have a Chromebook will be coming here. Or like last semester, I had a student with a really nice Windows laptop that she just preferred to take the quizzes and tests in class. Fewer distractions. She said she had children at home, so.
And the tests are going to be open note, like we'll be able to use our notes on them.
Let's answer that.